Hi dear students. So again Riyaz sir. So we have a new question in front of you. It's a very good question. Okay. First I will go through the question for you to understand. So the x and y coordinates of the particle at any time are x is equal to 5t square minus 2t square minus y is equal to 10t respectively, where x and y are in meters and t in seconds. Okay. The acceleration of the particle at a time t is equal to 2 seconds is. So this is the question actually. So how we can do this question? So let's analyze. So they have given you x and y coordinates. So what we need to find? Acceleration. So again what we need to do here is from the distance in the two coordinates, that is x and y with respect to time, we need to convert that into the respective acceleration. So first we should understand how to arrive at acceleration using distance, which is a function of time. Okay, so let's see that, then we will go to the answers. So we know that, so if you have distance given as a function of time, then velocity can be obtained as v is equal to dx by dt, where x is a function of time, I can write like that, then divided by dt. So this is how you will get the velocity term. Now you need to arrive at acceleration. Then acceleration is given by dv of t. So here velocity is a function of time divided by dt. So if you differentiate it, you will get acceleration. So this is the fundamental you should understand regarding this question. Okay, so I hope you have already learned this in theory sessions, so you might be knowing it. So let us now write actually what is x here, x coordinate. So x coordinate is 5t minus 2t square. Okay, 5t minus 2t square. So let's write that. So x of t, okay, so x of t is given as, okay, 5t minus 2t square, and y of t is given as 10t. This is given, correct? Now let's calculate what is velocity. Now since the distance have two components, x and y coordinates are there, the velocity will also have two coordinates, so we can mark it as vx with respect to time. It will be d by dt of x of t. Okay, so once you differentiate this, what you will get? 5t on differentiation, you will get what? We already already know the basics. I am repeating the basics one more time. That is d by dt of t raised to n is given as n into t raised to n minus 1. So this is the fundamental of differentiation. You are already learning this in maths, but you should know this. Okay, so on applying the same thing, you will get it as 5, okay, minus t square. So let's write 2 into t raised to 2 minus 1. So you will get it as 5 minus 4t. Okay, now let's similarly find out what is vy of t. Okay, vy of t, let's calculate. So vy of t, how you can do it? Okay, I will add one more paper here. Okay, so we need one more paper. So vy of t, similarly I can write it as d by dt of y with respect to t. Okay, now differentiate 10t similarly, so you will get 10, correct? Because this is t raised to 1, so 1 into, how it will come? I will write it maybe for your understanding, 1 into t raised to 1 minus 1 it will be, and any number raised to 0, t raised to 1 minus 1 is 0, so t power 0, so it would be 10. Okay, so if you know the differentiation, it is well and good, it's very easy. So now you got vx and vy, two components. Now we need to get the acceleration. So let's do the calculation for acceleration. Okay, all of you listen. Okay, so what would be acceleration, sir? So we know that acceleration will also have two components. So let it be ax, then ax will be d by dt of vx of t. Okay, so if you differentiate vx of t we already know 5 minus 4t. So we know on differentiating a constant, differentiation of a constant will be always 0. Let me write here, differentiation of a constant. So you have a constant here, let's assume a constant is there. Constant can be any numbers. Numbers are always considered as constant. On differentiating that, it will become 0. So this is another fundamental you learn from max. Okay, so this is 0. So 5 on differentiation will become 0 minus, we have the next number, that is 40. So 40 on differentiation, what it will become? 4 into t power 1. So that is 1 into t power 1 minus 1. So we will get this as minus 4. Okay, meter per second square, since it is acceleration. And similarly ay the component, we know that is d by dt of, okay, that is vy, which is a function of time. But here comes, we know that vy is already 10 is a constant which on differentiation will give you 0. Now what is the resultant acceleration? So the resultant acceleration a, we know that, which is nothing but square root of ax square plus ay square. Okay, and we know that ay is already 0 and ax is minus 4. So we can put it like minus 4 into minus 4. Okay, so that will come around as 16. Okay, that will come around as 16 and it will be 4. Okay. Okay, so we calculated the net acceleration a is equal to ax square plus ay square minus 4 into 4 root of 16, 4 we will get it. Okay, so that is 4 meter per second square. So we will see, we will look out the options, and but here we need to consider one thing. Here we are taking the magnitude. This is the magnitude of acceleration what we are getting here. Okay, so if we consider the direction also, we understood like in the ay there is net acceleration is 0. So ax is the only component that is giving you the acceleration. So we need to consider this minus also, considering the direction. So in the options, it can be minus 4 meter per second square should be the correct answer. Okay, this minus is coming since we are considering the direction also. So I am writing here direction is considered. Okay, minus indicates the direction part of the acceleration. So in this question you can see, even though the component has velocity in two particular direction, but acceleration happens only in one particular direction. Okay, so that's it. So let's go to the options and we will mark that. So answer should be option 2 should be the correct answer. Okay, so minus is coming since we are considering the direction. Okay, and thank you. So keep listening to this channel. You will get continuous questions on physics. Okay, and don't forget to subscribe it. Thank you.